Yeah, good morning once again. Sakari is here, and for today we'll be taking the question six on the screen. Question six, it's an A-level question, and I hope that we follow through and we are impacted one way or the other by virtue of how we are going to solve it. So the question reads that 4x squared plus 8x plus 3 is equal to a bracket x plus p all squared plus c. We are told to find the values of the constants a, b, and c. So apparently, we have been charged to express, our expression on the left-hand side, to stay in the form of what we have on the right-hand side. So that's our charge. And some people might go through the route of expanding the right-hand side and try to create a simultaneous equation of some sort. That is an option. So if you can solve the question, using that method, you can also try it out and, let me know if you encounter any form of glitch whatsoever. But how we are going to solve this question is to use the completing the square method. So the first thing we are going to do here, let me write out the question. We have 4x squared plus the 8x, then plus 3. So the first thing here, I would be grouping it this way, such that the 4x squared and the 8x are grouped together and the 3 left on its own. So we can have, if we factorize out the 4, and we know 4x is common, but we factorize out the 4. So we can still have the expression in terms of the x squared. And we can still have the expression in the order 2, since it's still quadratic. So we have 4, right? We open our brackets and we have x squared plus 2x. We close the brackets. That is just what we have here from this point to this point. And we still have the plus 3 here. So if we attempt to complete the square in the brackets, the step for completing the square is to take half of the coefficient of x. And in this case, the coefficient of x is 2. So half of 2 is 1. So we have 4 into bracket x squared plus 2x. Half of our 2, half of 2, which is the coefficient of x, is 1. And the step is for us to square it. So to complete a square, you take half the coefficient of x. Then whatever you arrive at, you square it. So I would have plus 1 squared. Right, I'll close my brackets. And we still have the plus 3. You notice here that what we have on the third line is 4x squared. 4x squared. If we choose to expand the bracket, we have 4x squared plus 8x, right, plus 4 and plus 3. Which you would all agree with me that it's different from the original question, which was 4x squared plus 8x plus 3. So there is an intruder, and the intruder in this form is the plus 4, which was introduced. So if the plus 4 leaves, we have our question intact. So all we need to do to remove the plus 4 is to subtract this expression from 4. Or to subtract 4 from the expression. So plus 4 minus 4 would attempt to cancel, and we are back to our original equation, but we won't cancel it. And we would leave it because from this point to this point is what we have here. So just have our -4, and that way, what we have over here, is now the same as the original question. So nothing has been done. Our question is still intact, but we've just introduced one or two things that would help us to complete this square. So if we have this, and we can have 4, because we have added the half of 2, which is 1. If we factorize what we have in the blue bracket, we should be having x plus 1 all squared. Then over here, the plus 3 minus 4 should be giving us a -1. So this way we have been able to express it in the form a bracket x plus the b squared plus c. And we can all see that our a is 4, our b is 1, and the c is -1. Even though so find the values of the constants a, b, and c. Your a is 4, your b is 1, and your c also is -1. So the first part of the question has been achieved. This step is straightforward, completing the square. If you have difficulties with completing this square, hopefully one of these days we will take a question and explain how to complete a square. So the first part, like I said, has been taken. And what is so significant about, so I'm just going to write what we got here. I'll write it here so we can have enough space to sketch the graph as was directed in the second part of the question. So what is so important about expressing or writing quadratic expressions in this form, in the form a bracket x plus b squared plus c, it helps us to sketch a quadratic. The first thing is, if we are going to sketch, 3 things have to be noted. The first thing we would note when we want to sketch is the nature of the graph, and in this case, our graph should be coming this way. How did we know? Because the coefficient of x squared, which is 4, right, is positive. If we had a -4x squared, then the nature of the graph would come in this form. Don't forget, when you are told to sketch, you are not drawing to scale, but you're just hitting the graph, at the right points that it should be hitting. What else should we take note of when we are sketching? We also take note of the minimum points. The minimum points, the minimum points. Also take note of the minimum points can be referred to as the turning points. So in situations where the graph comes the other way, then we expect to have a maximum point, which also is the turning point. And we can also choose to find the points where the graph cuts the axis, the intercept, on the both axes. which in this case was set as the coordinate axis. The coordinate axis, the coordinates, the coordinates, the two axes, that's the x and the y axis. So that is quite important. So the first thing is we already know the nature of the graph. It's going this way. The minimum point is the point minus 1, 1. Sorry, minus 1, minus 1. Why is that so? If you express a quadratic expression in the form a bracket x plus the b squared plus c, now your b here, if you express in this form and with a minus b, and with a minus b, right, your b here is the x coordinates at the turning point, and your c is the y coordinates at the turning point. So we have been able to establish the nature of the graph. We already have our minimum point. Why did we say minus 1? Because over here, if you have a plus 1, then it's minus 1. Because if your minus p is equal to 1, then your b has to be minus 1. Right? Then for the y coordinate, it's whatever we have as our c that will pick as the y coordinate. So our minimum point is the minus 1, 1. And that has been taken care of. So let's clean off and sketch with the information that we already have. Let's clean off and sketch with the information that we already have, even though we have a third information that we still have to find. But let's just sketch with the information that we already have. We said the graph goes this way. It's turning at the point minus 1, 1. So x is minus 1. Let's take here as our minus 1. And our y also is minus 1. So it's turning at this point. So my graph would come this way. Turn at this point. Apologies. And the graph would come this way and turn at this point here. And it's probably going to go the other way, this way. But that's not even the problem, because we are still in the process of sketching, and we need to find other things. What are the other things? We have been able to establish the nature, the turning point, which we said is 1 minus 1. It means your x is 1. I would just shift the minus 1 on the x to fit here as the minus 1 here. And of course, your y also is minus 1 at the turning point. So we need to find the point where the graph cuts the x-axis, and also the point where it cuts the y-axis. And once we have been able to find that, then we can easily go about finding or drawing or sketching the graph in the end. Now, if we take back the equation, If we take back this equation, what is the equation? The equation y equals to 4x squared plus 8x plus 3. We can say that on the y-axis, your x is equal to 0. On the y-axis, your x is equal to 0. And if your x equal to 0, we have our y equal to 0 plus 0 plus 3. So the y is equal to 3, which simply means that this graph is supposed to cut the y-axis at the point y equals to 3, that has been established, and we notice here that is not cutting at y equals to 3. So there will still be a need for us to look into the sketch one more time. So I said on the y-axis, your x equal to 0, and that was what helped us to achieve that the y-intercept is at the y equals to 3. Also on the x-axis, your y is also equal to 0. So if your y equal to 0 on the x-axis, we can come back to this equation, and we have 0 is what? 4x squared plus 8x plus 3. If we attempt to factorize what we have here, we have 4x squared plus 2x, 2x plus 6x plus 3, which factorizes as 2x into brackets, the 2x plus 1. Then we also have plus 3 into brackets, 2x plus 1. I'm just trying to manage the space we have here to solve the questions. So I'm not taking time to explain how to factorize, because the purpose of this question is not to teach how to factorize. However, I'll be making some videos, as the day go by, treating some topics, of our challenge. So we have 2x plus 1 and 2x plus 3 as the factorized form of this equal to 0. So we'll have our x to be minus half or the minus 3/2. And we notice here again that it means the graph is supposed to cut the x-axis, at the negative part. So we would go back and sketch this all over again. So it's always good to get all what you need to get before sketching. It's not enough to just have those two information, the nature and the turning points. Now that we have everything, I would like to extend this line. I don't mind. We have the x as minus half, so we have a minus 1 somewhere. We have minus 1. We have minus half. We have the minus 3/2, all playing their parts. So if I erase the whole thing here, we can go back to the question to where we are. We are told to sketch. We already have all the information that we need. It's turning at minus 1, 1. It's cutting the x-axis at minus 3/2 minus half, and cutting the y-axis at 3. So if I attempt to sketch, it just come out this way, it's cut this way. It goes back here and goes back up. So we can call here our 3, right? We can call here 3, and which is the point where the graph cuts the y-axis, which have been found before now. And it's turning at our minus 1, 1. Sorry, minus 1, minus 1. Right, so what is giving you your 4 marks here is your ability to hit the graph at the right point. I'll use a red tick to show all the points that are very important in this question. So this is a very important point. This is an important point. This is an important point. Of course, the turning point is also very, very important. So once you're able to show all that, of course, the nature of the graph, then you earn a right to having the 4 marks as is stated in this question. Like I said, some topics, that was hidden in this question, I had to rush through them, but with time, we would make our time to explain how to factorize, how to complete the square, and the likes. Thank you so very much for watching. Hit the like button, subscribe, and let's impact one another. If you have a different way of solving it, of course, I also want to learn. No one is an epitome of knowledge. So let's learn from one another. Let's solve questions together and impact the world. Thank you so very much and have a wonderful day ahead.